Here is something that has been quietly bothering astronomers for almost 4 years now, and the more you sit with it, the stranger it gets. Every time our most powerful telescope turns to look at the oldest, most distant part of the sky, the same thing keeps showing up. Tiny points of light, intensely, deeply red, scattered across nearly every deep image we take. Not one or two of them, hundreds, all crowded into the first billion years after the Big Bang, back when the universe was just getting started. And here is the part that should grab you. When astronomers tried to figure out what these things were, they did the obvious thing. They reached for the categories we already have. Maybe they are old galaxies, far away. Maybe they are hungry black holes hidden behind dust. Maybe they are tight little clusters of stars. Good guesses, all of them. And one by one, every single guess was tested against the data. And one by one, every single guess failed. Think about how unusual that is. We have been studying the sky for a very long time. We have names and boxes for almost everything out there. But these little red dots, as astronomers ended up calling them, do not fit in any of the boxes. They are not behaving like anything we have ever catalogued before. And this is not some tiny footnote in a survey somewhere, because that first billion years is the most important chapter in the whole story of the cosmos. It is when the first stars caught fire, when the first galaxies pulled themselves together, when the first giant black holes appeared, somehow already enormous, in a way our physics still cannot fully explain. The little red dots are sitting right in the middle of all of it. Whatever they are part of the story of how the universe became the universe. And the leading idea right now, the one gaining ground month by month, is genuinely startling. It is that these dots are not just a new kind of galaxy. They might be an entirely new kind of object, something we did not even know could exist. So tonight, we are going to work through this like a detective story, because that is exactly how it unfolded. We will start with what these dots looked like and why they stopped scientists in their tracks. We will line up the suspects, the ordinary explanations, and watch each one fall apart. And then we will arrive at the strange, beautiful answer that astronomers are now circling. An object so odd, it sounds made up, and a star that is not a star at all. But let me make you one honest promise before we begin, the same one I always make. The observations here, the things we have actually measured, are real, confirmed, solid. But the explanation, the story of what these dots truly are, is still being argued over right now, in real time, by scientists who do not all agree. And every time we cross from what we know into what we are still guessing at, I will stop, and I will tell you plainly. I am not going to hand you a theory and pretend it is a fact. And before we go on, one small thing. A lot of you come back for these journeys but have not actually subscribed yet. If you want to keep wandering out to the strange edges of the universe with us, every Wednesday and Sunday, just subscribe and tap the bell so the next one finds its way to you. Now settle in, get comfortable, and let the day slip away. Because we are about to go looking at some of the most puzzling little objects anyone has ever found. And nobody, not even the people who discovered them, is entirely sure what they are. So to understand what these dots are, you first have to understand the machine that found them, because none of this happens without it. The James Webb Space Telescope was built to do one thing better than anything humans had ever made before. It was built to see the very first light in the universe. Everything about it was designed around that single goal. Its main mirror is 6.5 meters across, coated in a thin layer of real gold, and it is so large that it could not fit inside the rocket in one piece. So the engineers did something almost unbelievable. They built it to fold up, like a piece of origami tucked away for launch, and then unfold itself once it was out in space, 1,000,000 miles from home, with no one there to fix it if anything went wrong. When you learn how many separate steps had to work perfectly for that to happen, It is a small miracle the thing works at all. But the mirror is not even the clever part. The clever part is what kind of light it was built to catch. Your eyes see what we call visible light. Reds, greens, blues, the ordinary colors of the world. Webb, on the other hand, was tuned to see something your eyes cannot. Infrared light. It is the kind of light you do not see, but you do feel. When you hold your hand near a warm stove, that heat reaching your skin, that is infrared, and Webb was built to see it. Now, that choice sounds strange at first. Why build the most expensive telescope in history to look at heat of all things? But there is a beautiful reason, and once it clicks, the whole thing makes sense. Here is the idea. The light from the earliest objects in the universe has been traveling toward us for well over 13 billion years. That is almost the entire age of the cosmos. And the whole time that light has been on its way, the universe has not been sitting still. It has been expanding, stretching, growing larger in every direction. And when space itself stretches, the light traveling through it gets stretched along with it. Its waves get pulled out, longer and longer and longer. So a wave of light that started its journey as bright, energetic, bluish light 13 billion years ago arrives here tonight pulled all the way out, long and low and slow, deep into the infrared. The color has literally been drained out of it by the expansion of the universe. There is a familiar version of this you already know. Think about an ambulance racing past you on the street. As it comes toward you, the pitch of the siren sounds high, and the moment it passes and speeds away, the pitch drops lower and lower. The sound waves are getting stretched as the ambulance moves away from you. Light does the very same thing. The more the universe has stretched a beam of light, the more its color has dropped, sliding from blue toward red and then past red into the infrared. And this turns out to be an incredible gift, because it means the stretch is a kind of clock. The more a beam of light has been pulled out, the longer it has been traveling, and the further back in time we are seeing. Every photon that reaches us is carrying a tiny timestamp written into exactly how stretched it is. Read the stretch, and you know how old the light is. So now you see why Webb had to be an infrared telescope. The oldest light in the universe, the light from the first stars and the first galaxies, is not blue anymore. It is not even visible anymore. The universe has stretched it clean out of sight into the infrared. And if you want to see the beginning of everything, you need an eye that can catch that stretched, ancient, invisible glow. That is exactly the eye Webb was given. So they built it, they folded it up, launched it, unfolded it 1,000,000 miles away, and pointed it at the deepest, darkest, oldest patches of sky they could find. And they waited to see the first galaxies of the young universe, exactly as they had always imagined them. And what came back in those first images was mostly what they expected, mostly. But scattered through those same pictures, sitting quietly among the galaxies, was something nobody had ordered, something that did not belong, and that is where we go next. So when astronomers pointed Webb at the deep sky, they already had a picture in their heads of what they would find. And it is worth understanding that picture, because the surprise only makes sense against it. They expected to see the first galaxies of the universe, and the first galaxies, everyone agreed, should look a certain way. Not the grand, graceful spirals we see nearby, not the smooth, settled shapes of old age, no. These would be galaxies caught in the middle of being born. Small, messy, lopsided, clumpy little things, full of gas, full of brand new stars lighting up for the very first time, awkward and unfinished, like the universe's rough first drafts. And there was one more thing everyone expected. These young galaxies should look blue, and the reason why is something you have seen with your own eyes without ever thinking about it. It comes down to temperature. A young star, freshly lit, burns ferociously hot, and hot things glow blue. You can watch this in an ordinary flame. Look closely at a candle or a campfire or the burner on a stove. Down near the base, where it burns hottest, the flame glows blue. Higher up, where it is cooler, it fades to orange, then red. The color of a flame is really just a thermometer. Blue means hot, red means cooler. Stars work exactly the same way. A galaxy packed with young, hot, newborn stars should glow with a bluish light. That blue is the signature of youth. It is the color of a universe just getting started, all fresh fire and new light. So this was the expectation. Point Webb at the deep sky, and you should see a field full of small, messy, blue galaxies scattered across the early universe like sparks thrown off a fire. And here is the thing that is mostly what they found. The deep images filled up with exactly those young, awkward, bluish galaxies doing exactly what young galaxies are supposed to do. The picture held together. The science of the cosmic dawn moved forward, right on schedule. But sitting in those very same images, quietly, in almost every single one, was something else. Something that did not belong at all. Little points of light that were not blue. Not messy, not clumpy or lopsided. They were the opposite of everything around them. Small, sharp, tightly focused points, like tiny pinpricks pressed into the picture, and they were red, deeply, intensely red, redder than almost anything else in the frame. In a sky full of blue newborns, here were these strange little red specks, and they made no sense at all. The first person to really stop and stare at this was a team running a survey called SEERS, and the timing is worth sitting with for a second. This was December of 2022. Webb had only been doing science for a few months. It had barely opened its eyes, and already, right away, it was showing us something we could not explain. SEERS had a simple job: stare into one small patch of sky, longer and deeper than anyone had before, and pull back the clearest possible view of the early universe. And when those images came back, they were stuffed with galaxies, thousands of them, loose and blue and messy, just as expected. But mixed in among all of them were these other things, these sharp little red points that looked nothing like their neighbors. At first, honestly, it was just a handful of them, easy to set aside, the kind of oddity you notice, raise an eyebrow at, and file away to look at later. A curiosity, probably nothing. But then more data came in, and there were more of them, and then more still. The handful became a crowd, and what had looked like a few strange specks began to look like a pattern, one that was not going to quietly go away. And that is the moment a curiosity turns into a genuine mystery. Because a couple of odd objects you can shrug off, but when the same strange thing keeps appearing again and again in image after image across different patches of the sky, you can no longer look away. Something real is out there, something the universe is doing on purpose, and nobody had the faintest idea what it was. So the hunt began in earnest, and the first question was the simplest one of all. Just how many of these things are out there? The answer, it turned out, was a lot more than anyone was ready for, and that is where we go next. So the hunt was on, and the first team to plant a flag on these strange objects was led by an astronomer named Ivo Labbé. In early 2023, his group published a paper in the journal Nature describing a whole population of these compact red things, sitting way back at around 600 million years after the Big Bang. That is deep in the early universe, and that paper landed like a stone dropped into a still pond. Because the moment it came out, other teams started digging through their own Webb data, and they kept finding the same thing, the same little red points, showing up in survey after survey, in patches of sky that had nothing to do with each other. This was not one group seeing what they wanted to see. Everyone was finding them. One of those teams was led by an astronomer named Jorrit Matthey, working with 2 more surveys, and it was his group that gave these objects the name that finally stuck. They called them little red dots. And honestly, you have to smile at that, because it is almost too plain, too simple for something this strange. These bizarre, category-breaking objects at the dawn of the universe, and we named them like a child, naming what they see in a coloring book. Little red dots, but the name caught on instantly, and it has been used ever since. And then came survey after survey, each one deeper than the last, with names like Jades and Rubies and Cosmos Webb. And with every new one, the picture got clearer and stranger, because the little red dots were not a fluke of one image or one telescope pointing. They were everywhere, hundreds of them, scattered across nearly every deep field we had ever taken. Wherever we looked far enough back, there they were, sprinkled through the early universe like they belonged there. But here is where it gets really interesting, because it was not just how many of them there were, it was when they were. When astronomers plotted out the little red dots across cosmic time, they noticed something that gave them chills. The dots were not spread evenly through history. They were bunched up in one specific window. They start showing up around 600 million years after the Big Bang. Their numbers climb, they become common, almost crowded. And then, a bit later, around 1 billion or so years in, they fade away. They thin out and quietly disappear from the story. Think about what that means. These objects belong to one particular chapter of the universe. A chapter that opened, ran for a while, and then closed. Before that window, almost none. After it, almost none. But during it, they were everywhere. It is as if the universe went through a phase, made these strange things for a stretch of time, and then stopped, and never really made them again. Astronomers actually have a word for this kind of thing. They call it an epoch, a window of cosmic time when some special set of conditions briefly exists, gets used up by whatever process depends on it, and then closes forever as the universe moves on and changes. And the little red dots seem to mark out an epoch all their own distinct chapter, tucked inside the larger story of the cosmic dawn. And that only deepened the mystery, because now you do not just have to explain what these things are, you have to explain why the universe made so many of them all at once, in one narrow slice of time, and then simply stopped. So this was the situation astronomers found themselves in. Hundreds of tiny red objects crowded into the first billion years, appearing everywhere they looked, clustered into their own strange epoch, and absolutely refusing to fit into any box we already had. Now, you might think a small red point of light would be one of the easiest things in the whole sky to explain. And normally, you would be right, a small red dot is usually a simple story. It is small because it is far away, and it is red for one of a few boring, well-understood reasons. Astronomers handle small red things all the time. This should have been routine. But the little red dots refused to play along, because when astronomers finally took their light apart and measured it carefully, they found 3 things. 3 specific measurements, and each one, on its own, was strange. Together, they broke the rules completely. They pointed to something that, by everything we knew, simply should not be able to exist. And those 3 clues are where we go next. So, astronomers took the light from these dots and pulled it apart. And this is a good moment to explain how that works, because it is the key to everything. When you pass light through a prism, it spreads out into a rainbow, splitting into all its separate colours. Astronomers do the same thing with starlight, and that spread of colours tells them almost everything. What an object is made of, how hot it is, how fast it is moving. The light is a fingerprint. So they took the fingerprint of a little red dot, and that is where the trouble started. Here is the first clue. When you lay out the dot's light across all its colours, you see something bizarre. There is a thin, faint trickle of blue light on one side. Then, suddenly, a sharp jump, and then a flood of red light on the other side, far brighter than the blue. If you draw that shape out, it traces a clean letter V, blue low on one side, red high on the other, with a sharp step in the middle. And that V is a real problem, because almost nothing in the entire catalogue of the universe makes a shape like that. Normal galaxies give a smooth, gentle curve of light. Dusty galaxies do too. Even a big feeding black hole gives something smoother. But the little red dots gave this strange, sharp V. Right away, they were speaking a language we did not recognize. Then came the second clue. And this one is genuinely hard to believe. These objects are small. Not just small for how far away they are, absurdly, almost impossibly small. Take our own Milky Way. It is about 100,000 light years across. Now, the little red dots, when astronomers managed to measure them carefully, came out at maybe a few hundred light years across, at most. In some cases, even smaller. That is less than 1,000th the width of our galaxy. Let me put that in a way you can actually feel. Imagine you shrank the entire Milky Way down to the size of a football stadium, all 100,000 light years of it packed into one stadium. On that scale, a little red dot would be smaller than a single seat in the stands. One seat, and yet, here is the impossible part. That one tiny seat is shining as brightly as the entire stadium, a whole galaxy's worth of light, pouring out of a space almost too small to imagine. That should not be possible. Nothing we know packs that much light into that little room. And then the third clue, which might be the strangest of all. Astronomers looked closely at the hydrogen gas glowing around these dots, and that gas was moving fast, terrifyingly fast. Its light was smeared out across a wide band of colours, and that smearing happens when gas is whipping toward you and away from you at the same time, on opposite sides of the same object, spinning around something at incredible speed. The numbers came out at thousands of kilometres every second. Now, gas does not just move that fast on its own. To fling a whole cloud of hydrogen around at those speeds, you need gravity, enormous gravity, a powerful, concentrated anchor sitting right at the centre, yanking everything around it. And in astronomy, there is really only one usual suspect that fits that description. A black hole, a big one. And then, on top of all of that, there was one more problem, a counting problem. Because when astronomers added up how many of these dots there were, the number came out roughly 10 times higher than any model of early black holes had ever predicted. Not a little more, 10 times more. When your count overshoots the theory by that much, it usually is not a small mistake in the math. It usually means the theory is missing something big, something structural, an entire piece of the picture that we simply did not have. So step back and look at what we are holding now. A tiny object, far too small, shining far too brightly for its size, giving off light in a strange V shape that nothing else makes, with gas swirling around it at black hole speeds, and there are 10 times too many of them. Every single one of those facts is strange, and they all belong to the same little object. So astronomers did the only sensible thing. They started working through the suspects, one at a time. The ordinary explanations that had solved 1,000 mysteries before this one. And they started with the most obvious suspect of all, the one that red usually points to, and that is where we go next. So, the first suspect is the obvious one, the one your gut jumps to. These dots are red, and in astronomy, red usually means old. Here is why a young star burns hot and shines blue, but as a star ages, it cools and drifts toward red. So a galaxy full of hot young stars looks blue, and a galaxy full of old, cooler stars looks red. Red means old. This rule holds up almost everywhere in the sky. So the first, most natural thought was simply, these must be old galaxies, packed full of ancient stars quietly glowing red the way old galaxies do. But there was a problem with that answer right from the start, and it was the timing. Remember where these dots are sitting, less than 1 billion years after the Big Bang. And if one of these things is already a mature galaxy, stuffed with old stars, weighing as much as our entire Milky Way, then you have to ask, how on earth did it get built so fast? Because galaxies are supposed to grow slowly. They pull in gas little by little. They make stars gradually. They take billions of years to become something as big as the Milky Way. But here was one, apparently fully grown, when the universe was barely a toddler. There simply was not enough time. It is like finding a fully grown oak tree just weeks after the seed was planted. Something does not add up. For a while, in 2023, this was actually the story going around. Headlines said Webb had found galaxies that were too big, too soon. Some people wondered out loud if our whole picture of the early universe was broken. It was a dramatic moment, but then astronomers slowed down and did the math more carefully, and the old galaxy answer fell apart in a way that is genuinely fascinating. Here is the problem. If all that light really is coming from stars, then you can count how many stars you would need to make a dot shine that brightly. And the number is staggering, because remember how tiny these things are. To shine as bright as they do, using stars alone, you would have to cram an entire galaxy's worth of stars into a space smaller than the little core at the center of the Milky Way. The stars would be packed unbelievably tight. And that is where it breaks, because think about what happens when you pack stars that close together. In our part of the galaxy, stars sit light years apart, with enormous empty gulfs between them. They almost never come near each other. But in a little red dot, under the all-stars idea, they would be jammed so close that they would be crashing into each other constantly. Collisions, night after night, all across the object. And stars are not soft. When two stars slam into each other at those speeds, it is violent. It throws off a huge burst of high-energy radiation, X-rays, the kind of light that screams across the universe and lights up our X-ray telescopes. So if these dots really were that densely packed with stars, the sky should be glowing with the X-rays of all those collisions. They should be blazing. So astronomers went and looked. They pointed our X-ray telescopes at the dots. And to squeeze out every last drop of sensitivity, they stacked hundreds of the dots together, adding up their light, hoping to catch even a whisper of an X-ray signal. And they found almost nothing. Silence. The X-rays that should have been pouring out simply were not there. And that closes the door, because you cannot have it both ways. Either the dots are nowhere near as dense as they would need to be, in which case stars cannot explain how bright they are, or they really are that dense, in which case they should be screaming in X-rays and they are not. Either way, the all-starlight answer is dead. There is even a hard limit in physics that says the same thing. Stars can only shine so brightly before the force of their own light starts to blow them apart. To be as bright as these dots, using stars, you would need stars shining so far past that limit they could not survive. They would tear themselves apart almost as fast as they formed. So the first suspect is cleared. These are not simply old galaxies full of stars. Something else is making them shine, and there was one obvious candidate left. The other thing in the universe that can outshine a galaxy, and that is where we go next. So here is the second suspect. And on paper, it looks perfect. A feeding black hole. Now, when you hear black hole, you think of something dark that swallows light. But a feeding black hole is the opposite. It is one of the brightest things in the entire universe. Here is why. When gas and dust fall toward a black hole, they do not just drop straight in. They pile up into a swirling disk, whipping around faster and faster, heating up to unbelievable temperatures, and hot things glow. So that disk blazes, pouring out light across every wavelength there is. We actually have a name for these. We call them quasars. A single black hole at the heart of a galaxy, feeding hungrily shining brighter than all the billions of stars around it combined. So, the idea was simple and elegant. Maybe a little red dot is a small early galaxy with a feeding black hole at its center, wrapped in a thick blanket of dust that soaks up the bluer light and lets only the red leak through. That would explain the brightness, the small size, and the red color. For a while, this looked like the answer. There is a nice way to picture it. Think of a campfire wrapped in a heavy blanket. You cannot see the flames directly anymore, but the heat still leaks through. The blanket itself warms up and starts to glow. Sparks and radiation escape around the edges. And if you have the right instruments, you can pick up every part of that story, even without seeing the fire itself. So astronomers made a list. If these dots really are dust-wrapped black holes, they should give off certain very specific signals. And astronomers went looking for each one, and this is where it gets strange. Because one by one, every single signal came back missing. The first thing they looked for was X-rays. A feeding black hole is a powerful X-ray source, and X-rays are sneaky. They carry so much energy that they punch straight through dust, through almost anything. So even if the light is hidden behind a blanket, the X-rays should still reach us. Our great X-ray observatory has been watching the sky for over 20 years. Astronomers pointed it at the dots, over and over. They stacked hundreds of them together to boost the signal, and almost nothing came back. The X-rays that a feeding black hole should blaze with just were not there. The second thing they looked for was warm dust, because if a black hole is glowing behind a thick blanket of dust, that dust should soak up the heat and glow itself in a particular kind of infrared light. Webb has an instrument built exactly to see that warm dust glow. Astronomers looked for it, and it was not there either. The signal was flat, where it should have been shining. The third thing was radio waves. Radio waves slip through dust as if it were not even there. So, if there were a hidden black hole in the middle of these dots, its radio glow should reach us untouched. Astronomers stacked radio observations of hundreds of dots, and the result came back empty again. And then, the strangest one of all, feeding black holes flicker. As clumps of gas fall in unevenly, and the disk churns and stutters, the brightness wobbles up and down over weeks and months. Astronomers have used this flickering for decades to spot black holes from across the universe. You watch a bright point of light for long enough, and if it flickers, you have probably found one. So they watched the little red dots. For years, many of them, and almost none of them, flicker. They just sit there, steady, unwavering, shining at the same brightness, in a way no normal feeding black hole ever does. So take a step back and feel where we have landed. Everything about the gas around these dots screams that there is a powerful black hole in the center. The gas is racing around at black hole speeds, that part is clear. But every single fingerprint a feeding black hole is supposed to leave, the X-rays, the warm dust, the radio, the flickering, is missing. All of it, gone. So now both of our natural suspects have failed. It is not simply an old galaxy full of stars, and it is not simply a feeding black hole hidden in dust. Both of the boxes we already had are empty. And that is the moment astronomers realized they might be looking at something genuinely new. A kind of object the catalogue did not have a page for yet, and that is where we go next. So here is where the story turns, and it happened in a way that almost never does in science. In March of 2025, 3 separate teams of astronomers working on different sides of the world posted their research within hours of each other. They had not planned it, they had not compared notes. 3 groups, chasing the same mystery down 3 different paths, and they all arrived independently at the very same answer. When that happens in science, when 3 teams stumble onto the same strange idea at the same moment, you sit up and pay attention, because it usually means the idea is real. The teams were led by Rohan Naidu Anna de Graaf, and Ivo Labbé, the same Labbé whose paper had set the whole thing off 2 years earlier. And here is the picture all three of them landed on. It is genuinely one of the strangest objects anyone has ever proposed. Picture a black hole, and picture it feeding, pulling matter inward the way a hungry black hole does. But now, picture that black hole completely buried inside an enormous cocoon of hot, dense hydrogen gas. Not a thin haze around it, a thick, opaque, colossal envelope, far larger than our whole solar system. The black hole sits deep in the middle of it, powering the entire thing, blazing away at the core. But you cannot see it, because the gas is so dense that it hides the black hole entirely. What you see, from the outside, is only the glowing surface of that giant ball of gas. Here is the simplest way to hold it in your head. Think of a hot coal buried inside a thick bank of fog. The coal is the energy source, the black hole, burning fiercely at the center. But you never see the coal. All you see is the fog, lit up from within, glowing softly. From far enough away, the whole thing just looks like one steady, glowing object. You would never guess there was a black hole hiding in the middle of it. Now, why does the gas glow red and steady instead of blazing with X-rays? This is the beautiful part, and there is a real piece of physics behind it. It is called photon trapping. When a huge amount of gas piles onto a black hole all at once, the light created near the black hole cannot simply escape. The gas is packed so thick that every particle of light gets absorbed, then spat back out, then absorbed again, over and over, like trying to walk across a room that is wall to wall with people. And every time that light gets absorbed and re-emitted, it loses a little energy. So the fierce, high-energy X-rays born near the black hole slowly get worn down, degraded, shifted, until by the time they finally crawl out of the gas, they are no longer X-rays at all. They emerge as softer, longer, redder light. The envelope launders the light, turning a violent core into a gentle red glow. And there is a version of this happening much closer to home. Inside our own sun, light created in the core does not fly straight out. It gets absorbed and re-emitted so many times on the way out that a single beam of light can take something like 100,000 years just to reach the surface. In the little red dots, that same trapping may be happening on a far larger, far more extreme scale, wrapped around a feeding black hole. And this is why they started calling these things black hole stars. Because from the outside, the object shines the way a giant star shines. A big, round, glowing surface of hot gas. But the engine inside is not a star. It is not nuclear fusion powering it. It is a black hole eating, a star on the outside, a black hole on the inside, a black hole star. And here is the moment it all clicks, because this one idea suddenly explains every single missing clue. Why were there no X-rays? Because the thick gas swallows them before they can escape. Why was there no warm dust glow? Because there barely is any dust. The redness was never coming from dust. It was coming from the hot gas itself. And why was there no flickering? Because the envelope is so vast and so dense that it smooths out every wobble from the black hole inside. A candle behind a thin curtain flickers. A candle behind a wall of fog burns perfectly steady. Every failed clue solved all at once by a single strange idea. And there was one particular object that made astronomers believe it. That is where we go next. So let me tell you about the one object that turned this from a clever idea into something astronomers really started to believe. It came out of a survey with a fitting name. It was called RUBIES, which stands for Red Unknowns, Bright Infrared Extragalactic Survey, and the name is almost perfect. Because that is exactly what these dots are, red unknowns. RUBIES was a big effort. Astronomers used around 60 hours of precious Webb telescope time to collect detailed light from about 4,500 distant galaxies, one of the largest hauls of its kind ever gathered, and buried in all that data was a single object that stopped everyone cold. The team gave it a name. They called it the cliff. The cliff earned its name because of the shape of its light. Remember that strange V pattern? The thin blue trickle, the sharp jump, the flood of red? Well, the cliff has the most extreme version of that ever measured in one of these objects. The jump in its light is so sudden, so sheer, that it looks like the edge of a cliff, and it is twice as strong as anything anyone had seen before it. If the little red dots were speaking a strange language, the cliff was practically shouting, and its other numbers were just as striking. The hydrogen gas around it is racing at about 1,500 kilometers every second. Even sitting some 12 billion light years away, so far back that we are seeing it in the deep early universe, it is still tiny, impossibly compact. Every single one of the strange features that make a little red dot strange, the cliff had them, turned up to the maximum. It was the purest, most extreme example anyone had found. And that is exactly what made it so useful. Because when you have the clearest, sharpest, most extreme example of a mystery, that is the one you can really test. The cliff was a perfect laboratory. If any of the old explanations were going to work, they had to work here. So the team, led by Anna de Graaf, did something rigorous and honest. They did not just decide it was a black hole star and move on. They took every competing explanation, every version of the old ideas, and they tested each one against the cliff, carefully, one by one. They tried to explain it as a galaxy full of ancient stars. They stretched that model in every direction, piling on dust, adjusting the mix of stars, trying everything. It failed. They tried to explain it as a dusty feeding black hole, the second suspect. It failed too. Every conventional model they threw at the cliff broke against it. Not one of them could reproduce that sheer, cliff-like jump in its light. And when they had ruled out everything ordinary, only one picture was left standing. A powerful source of light, almost certainly a black hole, sitting at the center of a dense, hot envelope of hydrogen gas. The black hole's star, it was the only thing that fit. The cliff was the clearest evidence yet that at least some of these little red dots are exactly that. Not ultra-dense galaxies, not dusty quasars, but this strange new third thing, a bright engine buried in a thick cocoon of glowing gas. And once the cliff pointed the way, the picture started to spread. By late 2025, the black hole star model had been published in major journals. And by early 2026, a larger study pulled together over 100 of these little red dots and argued that the whole family of them might be powered the same way. What had started as one strange object had grown into a possible explanation for the entire population. But now I have to keep my promise to you and be completely honest, because as good as this story is, it is not finished. The black hole star is the leading idea right now. It is gaining ground, it fits the evidence beautifully, and more astronomers are coming around to it. But it is not proven, it is not settled, it is not the only answer still being seriously defended. In fact, several other teams, some of them using the very same data, have put forward their own explanations, and a few of them are genuinely wild. Ideas that reach back even further into the beginning of the universe, to the very first stars that ever existed, and to black holes that formed in ways we have never confirmed. The mystery is still alive, the debate is still open, and those other ideas deserve to be heard. That is where we go next. So, the black hole star is the front runner. But science does not work by everyone agreeing at once, and it should not. So let me walk you through the other ideas still very much on the table, because any one of them could still turn out to be right. The first competing idea reaches back even further in time than the black hole star does. Some astronomers, including a team at Harvard, have proposed that at least some of these dots might be the universe's very first stars. but not stars like anything we see today. The earliest stars, the theory goes, were monsters, enormous, thousands of times heavier than our own sun, and they were made almost entirely of the two simplest elements, hydrogen and helium, because in that early moment, the universe had not yet made anything heavier. These giant first stars would have burned incredibly bright and lived incredibly short lives, blazing for just a few million years before collapsing. And in the process, they may have formed the very first black holes. In this picture, a little red dot might be one of these primordial giants, or a nursery where they lived and died, right at the moment the first black holes were being born. The second idea takes a different road to a similar place. Normally, we think a black hole can only form after a star has lived its whole life and then collapsed. Star first, black hole second. But there is another possibility called direct collapse, and it skips the star entirely. The idea is that in the special conditions of the early universe, a vast cloud of pure, pristine hydrogen gas could collapse straight down into a black hole all at once without ever becoming a star first. No slow-burning life, no stellar death, just gas falling inward and becoming a black hole directly. Some astronomers running detailed computer simulations of the young universe have found that these freshly formed direct collapse black holes, still sitting in the clouds they were born from, naturally produce many of the strange features we measure in the little red dots. And the third idea looks in a completely different direction, not at the black holes and not at the stars, but at the invisible scaffolding that holds galaxies together. Because almost every galaxy sits inside an enormous halo of dark matter, a kind of unseen skeleton, and those halos almost always spin. But one researcher has suggested that the little red dots might live inside extremely rare halos that barely spin at all, and that tiny detail changes everything. Because in a normal spinning halo, gas swirls out into a wide, flat disk, the way water spirals around a drain. But in a halo that hardly spins, the gas has nothing to hold it back. It just falls straight inward, piling up into a tight, dense, brilliantly glowing center. In this view, the dots are not strange because the physics inside them is strange. They are strange simply because they live in one of the rarest kinds of place the universe can build. So there they are. 3 more ideas, all serious, all argued for right now in real journals. The first supermassive stars, direct collapse black holes, gas funneled into the heart of rare, still halos. And you might be tempted to feel frustrated by that, to wish someone would just tell you the answer. But look at it differently, because here is the beautiful thing. Notice what every one of these ideas has in common. Whether the little red dots turn out to be gas-cloaked black holes, or the first giant stars, or black holes born straight from gas, or objects shaped by rare halos, they are all pointing at the same deeper truth. They are all telling us that the early universe was doing something we do not yet fully understand, something our current picture does not quite capture. Every one of these theories is a different guess at the same missing chapter. Because our best model of the cosmos was built mostly from studying the universe nearby, the mature, settled, grown-up universe we can see clearly. But that very first billion years is a distant, difficult frontier. It is the hardest part of all of history to observe, and the little red dots are sitting right in the middle of it, refusing to fit, quietly insisting that something was happening back then that we have not figured out yet. And that is not a failure of science, it is the opposite. It is science working exactly the way it should, right at the edge of the known. So what does it all mean in the end? That is where we finish. Let me give you the idea I find the most beautiful. If the black hole star picture is right, then the little red dots are not just a new kind of object. They might be a moment, a phase, a stage in the life of a black hole that we have never caught before. Think about it this way. We already know the universe is full of supermassive black holes, sitting quietly at the centers of galaxies, including our own. And some of them, the quasars, blaze openly across the cosmos, feeding in plain sight, but we have never really understood the in-between. How does a black hole get from its small beginnings to a giant blazing quasar? What does that middle step look like? The little red dots might be that middle step. A supermassive black hole, while it is still young, still growing fast, still buried inside the very gas it is feeding on. Not yet broken free, not yet blazing openly. Just a hidden engine, wrapped in a glowing cocoon, doing the quiet, hungry work of becoming a giant. If that is true, then what we are looking at is a kind of cosmic chrysalis, the wrapped up, in-between form of a black hole, caught in the act of growing up, before it finally sheds its cocoon and emerges as a quasar for all the universe to see, and that would fill in a missing page. A chapter in the story of how the universe built its giant black holes that we never even knew was there. That, all by itself, would be extraordinary. But I want to end on something a little different, because you have to notice what has really happened here tonight. We built a telescope, we pointed it at the oldest, faintest, most distant light there is, and it showed us something that fits nowhere in everything we already knew. Hundreds of tiny red objects crowded into the dawn of the universe that none of our categories can hold. And here is the part I love. We still do not fully know what they are. Right now, tonight, as you listen to this, there are astronomers around the world staring at this exact mystery, arguing about it, testing it, publishing papers that contradict each other, chasing it down. The story is not finished. It is being written in real time. And I think there is something wonderful in that. We are used to science handing us finished answers, the tidy facts in the textbook, settled long ago. But that is not what discovery actually looks like from the inside. This, right here, the little red dots, is what it really looks like when humanity finds something new. The confusion, the failed guesses, the wild ideas, the slow, patient, honest work of figuring out something that nobody has ever understood before. You are not hearing about a discovery that happened. You are watching one happen, and you happen to be alive for it. Think about that for a second. For almost the entire history of our species, these dots were simply invisible. Their light was falling on the Earth all along, drifting down for billions of years, but we had no eye that could catch it. And then, in the span of just the last few years, we built one, and the universe showed us something we did not even know to look for. A possible new kind of object, revealed for the very first time in our lifetime in front of us. Somewhere out there, more than 13 billion light years away, these strange glowing things have been shining since the universe was young. They shone through the entire age of the dinosaurs. They shone while our ancestors first looked up and wondered. And their light is only reaching us now in our brief moment, landing in the mirror of a telescope we were just barely clever enough to build. We may not have the final answer yet, but we are the first humans who ever got to ask the question with real evidence in our hands. And that, more than any tidy answer, is the gift. To be here, at the edge of the known, watching the map of the universe get one strange new object larger, right before our eyes. Thank you for sitting with this mystery with me tonight. If it gave you a little of that wonder, share it with someone who loves to look up and ask what else is out there. And if you would like to keep chasing the strange edges of the cosmos with us every Wednesday and Sunday, you know what to do. Until the next journey, rest well, keep wondering, and never stop looking up.